the thin lens equation, we have one of the two kinds of lenses. Convex lens, as you can see, this convex lens is also called converging lens. All the rays that are parallel to principal axis, they converge at one point, and we all of the positions of the objects give you the image at the other side of the lens, and this image which is on the other side of the lens is called real image. And only one position of convex lens is where the image will be on the same side of the object, it will be virtual. So if object is at this position behind 2f, at 2f, in between f and 2f, f is the focal point, or at the f, the image at the f will be at infinity. At rest position, it will be on the other side of the lens that you can see here, convex lens. But if the object is here between f and the optical center, that I can show you a figure here. In this case, what will happen? The image will be on the same side, like this. If you see the object is here between f and optical center, this is the object, so image will be on the same side. So this is the only one condition that image forms is virtual, and this virtual image will be having, you can say, a negative distance of the image, negative, you can say, position. So here I'm going back to the point. What I'm going to start is, today we are going to talk about lens equation. The lens equation is the relationship between the focal length. You can see here, focal length is the distance of optical center to the principal focus, and then object from the lens is distance of the object. So if I can mention here that f is known as focal length, this is focal length. Then DO is distance of the object from the lens. You can say object distance. And then what is DI? DI is the distance of the image from the lens. You can say image distance. So here I would like to mention one more thing, that height of the image is HI. This is size of the image. And then HO is the size of the object, image size or object size. Okay, now these are the five, you can say, values that we need to know for the different lens equation to solve the problems. Here is one more thing that we need to know before we start: conventions. What are the sign conventions? If the lens is convex or converging, your focal length is considered as positive always, because this is real. And for the concave or diverging lens, your focal length is negative. Distance of the object is always positive for both of the lens. Distance of the image is positive if it is on the other side of the lens. As you can see, the figure drawn here, it is on the other side of the lens. Object is on the left, image is on the right side, so this is positive. But if image and object are on the same side, we will say this is negative. So distance of the image is positive if it is on the other side, it will be negative if it is on the same side. For concave, it is always negative. For convex, it will be positive always. Only one condition I showed you: when it is used as magnifying glass, we will use it as negative, and it will be on the same side of the this. Now, what is the lens equation? Lens equation for both of the lens is 1 over f, 1 over do plus 1 over di. We will follow the sign conventions, use this equation, and it will be whatever is unknown we can find. The other thing is magnification. Magnification can be calculated in two ways. It is hi over ho, size of the image over object, or it is distance of the image to the distance of the object with negative sign. So you can use both of them separately, one of them where it is dependent on the required position. And the third thing is, one is this lens equation, second thing is the magnification, and the third thing is, if they ask you to find power of the lens, so power of the lens is 1 over f. But please, All of these measuring quantities, length, size, height is in centimeter here in the lenses. But when you find power, you will use focal length in meter. So this is the only thing that we will use in meter, then we will find the power. Okay, there is another situation when it is a concave lens. I can show you the figure is like this. So in case of concave lens, I told you focal length will be negative, distance of the object will be positive, distance of the image will be negative, but the equation will be 1 over f 1 over do plus 1 over di. Whenever they ask for the position, I will use this. For the magnification, you will use hi over ho or minus di over do. So we will use this one with the sign convention. Let us start with the first example. If you look at this example, what do we have? We have an image of the leaf that is formed on the other side. Ahmed, when the image is on the other side, it means the distance of the image is positive. So what do we have here? We are asked to find the position and size. What is position and size of the image? Position, di is position you have to find, and size of the image is hi you have to find. So for that we need two equations. First, distance image we will use for the thin length equation, 1 over f 1 over do plus 1 over di. Now here I need di, so I just rearrange it. 1 over di is equal to 1 over do 1 over f minus 1 over do. I can also simplify it as di is equal to f times do over do minus f. So here, distance of the image, it should be positive. Why? Because it is on the other side of the lens. F is focal length. Here it is given that is plus 50 millimeter. So millimeter should be converted into centimeter. So I will use 50 divided by 100 or 10. It is 10. So this is 5.0 is the focal length time distance of the object is 1. So 1.0 is distance of the object. So 1.0 minus 5.0. What is this? Was 1. This was 100 centimeter. I need to convert. So this is 100. 1 meter mean 100 centimeter. So this is 100. So what is it? This will become 5 times 100. 500 over 95. Now it is correct. So 500 over 95 is how much? Because you need to convert meter into centimeter. So this is 100 centimeter. So 100 over 19 is how much? 5.26 centimeter. So we got it positive, it means it is correct. Now getting back to the other point, when we are asked to find the height, we have distance of the image 5.26 centimeter. Here they didn't give us magnification, they gave us the size of the object. Use negative di. Yes, and with the height. So you will use negative di over do is equal to hi over ho. So you are asked to find hi. So hi will be equal to, you can say hi is equal to negative di 5.26 times ho is how much? 7.6 over you have do. Distance of the object is how much? 100, right? Negative. So there is a negative sign with the answer. So height of the image is what this negative sign will represent? 0.39976. So negative 0.4. What is this 0.4 mean? It means that it is smaller, and negative mean inverted. Where must be the insect be placed? Mean they want us to find DO, distance of the object they want. Where must be the insect placed? That is 25 centimeter focal length. Virtual image, because it is on the same side. So it will be virtual image, automatically image distance will be negative because it's on the same side. So I'm going to find DO, and also if they are asking something, no, they are not asking for the magnification, but only DO. So I'm using 1 over F DO plus DI. So when you need 1 over DO, 1 over F minus 1 over DI. So you can also say DI minus F. So first you will multiply here F times DI, DI minus F. So DO, distance of the object, will be 25 times negative 20 over negative 20 minus 25. So how much is DO? 100 over 9, 11.2. 100 over 9, 11.2. No, my question to you is, I told you in the beginning that object is always positive. So here it is justified your distance of the object. Why? Because actually an object is present in front of lens. There is an actual object. So its distance is positive, and we got here a positive angle. Distance will be negative. So we put negative for DI because it is virtual image. And also, if you want magnification, you can also use the formula for it. You have both things. So let us find magnification. From the lens on the same side as the. Yeah. So if they ask for magnification, you can use either minus DI over DO. What is DI? DI is negative into negative 20 over DO we found is 11.2. So your image that you are getting is positive now. It is 1.8. So 1.8. So it is almost 2 times bigger. It is enlarged. 1.8 times enlarged, and Y sign is positive now. Magnification positive because it was upright. I told you when image is upside down, you put negative. You were asking me, and now it is upright, so this is negative. So here, negative will automatically go away. Yeah. So can you just do this one with me? You have an object placed 10 centimeter, and focal length is given in converging lens. Determine the image position and size. Image position means you are asked to find DI. And for DI, yes, DI is what? DO times F, DO minus F. If you can use only 1 over F, 1 over DI, 1 over DO, it's okay. Yeah, it's the same. So DI is, DO is 10 times 15 over 10 minus 15. Why is this DI negative? Jawad, why DI is our answer is negative now? This is virtual on the same side of the lens. Look, object is O here and I is here, same side. So that's why. So what is negative? 30? Yeah, negative 30 centimeter. Now, they ask for the size. So when the size, it means they need height, HI. So HI is negative DI times HO over DO. So negative DI minus 30 times height of the object. Is it given here? So keep it HO, no problem. Over what is DO? 10. So your answer is height of the image is 3 times size. So you can say the image is 3 times larger image. 3 times large image. So object is 3 times smaller. So if object is 1 centimeter, so image will be 3 centimeter. So we don't need value, we can just justify the size. Now they are saying use the ray diagram to send. So ray diagram is already drawn here. I told you in the previous lesson also, when object is here, you need 2 of these 3 rays. So if you want me, I can redraw it here. Let me draw it here. So for example, this is the convex lens as a magnifying glass. This is your lens. Here is the object. This I show O. Now I am going to change the color just to show you the rays. I remember I told you the first ray, which is parallel to the principal axis. This is the ray parallel to the principal axis. This principal axis parallel ray, after passing through the lens, should pass through principal focus. This one you wrote. So if this is principal focus, same distance here is principal focus, right? Okay. Now I just uh, make it same. The second one, if passing through optical center, it will go straight without any change. And the third one that seems to come from the optical center, this ray will become parallel. Okay, these are the three rays. Now, these three rays are spreading away. How image can form? So virtual image is by extension of the rays backward. So I am going to extend these rays because actual rays are not going to meet anytime. So I am going to extend them backward. When I extend them backward, what we will see? This ray, the first ray is going backward here.
Focal plane.
Image focal plane, that is when their rays are parallel. These rays are not all parallel. One is parallel to the principal axis, one is from optical center. So this is not that case. That case is rays are parallel to each other. These rays are not parallel to each other. Okay, now this is first ray. The second ray that is coming from here, I am just going to extend it from here. Let's say it is meeting the first ray here, and the third one, this one, if I try to meet this ray, it should be a little bit extra, but I just make it here. So these rays are meeting, for example, at this point. So this is the image formation. This is the image. So this is the ray diagram for the image formation. So we can see the image is bigger and it is also on the same side. So the distance of the image is negative. Size of the image is positive because it is upright, but it is virtual image. Focal length is positive as it is. Okay, just to have a quick uh, recap for this one, I just need this one. The power I didn't find. So there, what is the power of this centimeter focal length? So power, you know that 1 over f, but f should be in meter here, 32.5 centimeter to meter, so 0.325. So can you find the power?
40 over 13.
So
30.01.
3. So 30 over 14, 14 or 13?
40 over.
Okay, sorry, 40 over 13. So this is 3.1. 3.1. Answer is in diopter. If you studied the optics, diopter is a unit we also use for the eyesightness. So diopter power. So B part is opposite to this. In this, you are asked to find focal length when power is given. Yes, 1 over power is negative 6.7. Why? Why this is negative? It may be concave, diverging lens. Yes, it is mentioned. It is not mentioned, but we will write is diverging because focal length will be negative here. So here for this case, focal length is negative what? 1 over 6.75.
0.148.
0.148 meters. But we will convert into centimeter, 14.8 centimeter, and this lens is diverging because our focal length is negative. Okay, just to have a quick review from the your review sheet if you like to, otherwise it's fine. So this one is our lesson about the lens equation and how to calculate the power of lens. Why? I will send you the link. How you know? Just let me finish, please.